First of all, a quick review about frequency distributions. When we are working with a normal distribution, we are using a line graph of the frequencies of different scores. Think back to frequency distributions. Along the x-axis are the different scores. Along the y-axis are the frequencies of each score. So if you have one score of 10, two scores of 20, 5 scores of 30, 3 scores of 40, and 1 score of 50, you have a distribution curve. It has a mean of 30, which is also the mode or the highest point on the curve. The standard deviation is 10.87 in this simple example. A score of 10, notice, was very uncommon. Most folks scored between 20 and 40 points, and a score of 50 was also very rare. Now let's look at a normal distribution. When scores are in a normal distribution, half of the scores are above the mean and half are below. The mean, the median, and the mode are all at the same point. Often we say that 50% fall under the area that's in the top half of the curve, and 50% are under the area of the bottom half of the curve. The normal distribution curve is built on probabilities. The probability that a score would be in the middle of the range is very high. The probability that a score would be way out in the tails is very low. Each of these vertical lines represents one standard deviation away from the mean. It is so rare to have a score more than 3 standard deviations out from the mean on either side that we don't even usually consider it. But in theory, it could happen, and so the curve never actually touches the bottom of the x-axis. 99.74% of the scores will fall within 3 standard deviations on either side of the mean. Now let's add z-scores to the distribution curve. Remember that a z-score basically measures the distance a score is from the mean. A z-score of 0 is at the mean. A z-score of +1 is 1 standard deviation above the mean, and a z-score of -1 is 1 standard deviation below the mean, and so on. So basically, all the z-score is showing is the standard deviations on either side of the mean. Finally, let's look at the probability of a score being in each standard deviation. This is where the height comes in and the area under the curve. In other words, what percent of the scores will be in each of those sections between the vertical lines I've drawn? Between the mean and 1 standard deviation on either side of it will be 68% of all the scores. Look at the area under the curve between those 2 red vertical lines. You can see that by far most of the scores are going to fall there, and it's over 2/3. Going out 1 more standard deviation on either side accounts for another 13.5% of the scores on either side, and so on. Notice that percentile ranks can now be lined up with the standard deviation. You know that 50% of the scores are below the mean, fall in the area under the curve below the mean. If you go up 1 more standard deviation, you're adding another 34% of the scores. So if you add the 50 to the 34, you get 84% of the scores. So that means 1 standard deviation is at the 84th percentile, and it all lines up beautifully.